In 1 week, a stealth MIT startup claims its agent beats OpenAI and Anthropic on computer control. China drops 2 open-source models that rival GPT-5. The US releases its own fully open weight models. And Nvidia trains an 8B coordinator that outperforms giants. The AI world just split into factions. A stealth MIT-founded startup, OpenAGI, claiming its new model Lux controls computers better and cheaper than systems from OpenAI and Anthropic. Lux, trained on screenshots and action sequences instead of text, reaches top score on the Tough Online Mind 2 web benchmark, far above OpenAI and Anthropic. OpenAGI says Lux learns by exploring computers autonomously, generating new training data, and improving itself in a feedback loop. The model also runs at about 1/10 the cost of leading competitors. Unlike most agents limited to browsers, Lux can operate full desktop apps like Slack and Excel. OpenAGI is releasing a developer SDK and partnering with Intel to run Lux on edge devices, with exploratory talks underway with AMD and Microsoft. The company now enters the rapidly growing but unproven market for computer-controlling AI agents. If Lux's real-world performance matches its benchmark results, it could signal that smart training strategies, not massive budgets, will shape the future of AI agents. Chinese AI startup DeepSeek has released 2 new models, DeepSeek-V3.2 and DeepSeek-V3.2-Speciale, claiming performance on par with or better than OpenAI's GPT-5 and Google's Gemini 3 Pro. The Speciale variant achieved gold medal results in major international contests. A key breakthrough is DeepSeek Sparse Attention, DSA, which cuts computation for long context tasks roughly in half, enabling the 685B parameter models to process 128,000 token inputs at dramatically lower cost. Despite using sparse attention, V3.2 matches or outperforms earlier models on long context benchmarks. DeepSeek's metrics put it in the frontier tier. Speciale scored 96% on AIME 2025, 99% on HMMT. V3.2 introduces continuous reasoning during tool use, solving complex multi-step tasks while calling code, search, and file tools without losing context, enabled by a massive synthetic training pipeline. In a major strategic move, DeepSeek released both models fully open source under MIT, including weights and training code. U.S. startup Arcee AI is pushing back with the launch of its first 2 fully U.S.-trained open-weight MoE models, Trinity Mini and Trinity Nano Preview. Both are free under Apache 2, available on Hugging Face and OpenRouter. Trinity Mini 26B 3B Active is built for reasoning, tool use, and long context up to 131K tokens. Benchmarks show it outperforming several similarly sized open-weight models. Trinity Nano 6B 800M Active is a smaller, more experimental chat model. The models use Arcee's custom AIME HMMT architecture, combining sparse experts with enhanced attention mechanisms for stability, efficiency, and long context reasoning. Arcee is already training Trinity Large, a 420B parameter MoE model using a 20T token dataset, expected in January 2026. If successful, it could become one of the only frontier-scale, fully open-weight models trained entirely in the U.S. The Trinity project signals a push for model sovereignty, full control over data, training, and weights, arguing that future enterprise AI will depend on owning the entire stack, not just fine-tuning someone else's model. Mistral AI is launching its biggest product suite yet. Mistral 3, a family of 10 open-source models designed to run anywhere, from smartphones and drones to enterprise cloud systems. The lineup includes the flagship Mistral Large 3, a multimodal mixture of experts model with 41B active parameters, plus 9 smaller Mistral 3 models optimized for edge devices. All are released under Apache 2, allowing full commercial use. Mistral's smallest models can run on devices with just 4 GB of RAM. The company is also building a full enterprise stack, including its Agents API, coding tools, AI Studio platform, and Lute chat assistant. Mistral positions its open-source approach as essential for transparency, data control, and digital sovereignty, a stance that has attracted government and public sector partnerships. Researchers at Nvidia have introduced Orchestrator, an 8B parameter model designed to coordinate tools and other LLMs to solve complex tasks. Despite its small size, Orchestrator achieved higher accuracy at lower cost than much larger models on tool use benchmarks, and matched user preferences for which tools to use. The model is trained with Tool Orchestra, a new RL framework that teaches small models to act as intelligent coordinators. Instead of relying on a single large model with a few basic tools, the system uses a lightweight orchestrator to route subproblems to the best specialized tools, or LLMs, much like how humans turn to domain experts or software systems when reasoning. Tool Orchestra trains the orchestrator through rewards that balance correctness, cost, latency, and user preferences. The team built an automated pipeline to generate thousands of verifiable training examples across 10 domains. Using this approach, the 8B orchestrator, based on Qwen 3-8B, outperformed large generalist models on benchmarks such as HLE, Frames, and Tau2 Bench. It selectively used heavyweight models only when necessary, cutting cost and improving efficiency. It also generalized well to new tools and pricing structures, making it suited for enterprises that use mixed AI stacks. Thanks for watching. Hit like, subscribe, and drop your thoughts below. See you next time.